Hello, ladies and gentlemen. This is trigonometry part 7. Okay, so we'll continue from where we stopped. That's ratios of special angles. Ratios of special angle 60 degree and angle 30 degree. Okay, so how do we arrive at values for sine theta, sine 60, cos 60, tan 60, or sine 30, cos 30, tan 30. Okay, so the first one we need to use here is an equilateral triangle. Equilateral triangle. And what is the condition behind equilateral triangle? I don't want to start writing a lot of stories, but you can see it's an objective questions. Okay, so an equilateral triangle, okay, has these are the condition. Okay, the angle in an equilateral triangle is equal. The sum of angle in a triangle is 180. Okay, and if we say that the angles in an equilateral triangle are equal, then it means that it is 180 divided by what? 180, 180 degree divided by 3, and 6 times 3, that's 60 degree. Okay, so it shows that each angle in the triangle is equal to what? 60 degree. So that's the condition for equilateral triangle. Okay, the angles in a triangle, all the angles must be equal, which is 60 plus 60, 120 plus 60, 180. Okay, now the other condition is that the sides are equal, are equals to 2, are equal. The sides are equal. If this is 1, this will be 1, this will be 1. But in this case, we're using 2. This is 2, this is 2, this is 2, or side 2. Okay? So, two conditions. The sum of the angles in a triangle must be equal. Okay? For equilateral triangle, which is equal to 60 degree. Okay? Because it's 180 divided by 3. Now, the sides that we're using is also equal. In case you see it in an objective question, they can tell you which one of the following describe equilateral triangle. Okay, A this, B this, C this, D this, something like that. So you should know the correct answer. Okay, from that you know from that from that description. So it's very simple. So now, what do we need to do to get our angle 60 and angle 30? We will divide this equilateral triangle into two equal halves. Okay, into two. We'll divide it into two, and that division is like this. It must be equal. Don't mind me. This one must be equal. We have a broken line that will divide this triangle into what? Into two. And if you are dividing it into two, you have angle 90 here, you have angle 90 here. So if I'm dividing 60 degree into two, so it means that this place and this place will be 30 degree, and 30 degree. So you can see it now. It means if I'm dividing this into two equal halves, okay, 60 will be 30, 30. And when this is a straight line dividing this angle into two, if it is meeting an horizontal line, this is a vertical line meeting an horizontal line, like I said, it forms a right angle triangle. An horizontal line meeting a vertical line, that angle is automatically a right angle triangle. Okay, it's automatically a what? A right angle triangle. Okay, in order not to waste much of our time, all we just need to do is just to come here and have that particular sketch. So this is the broken line that divides the 60 degree. You have this one here. Okay, that's not straight enough. Okay, so you have this here, then you have this here. Okay, let's take one side. So this is the 30 degree, this is the what? 60 degree, and this is the angle 90. Okay, let's tag this as what? General one, A, B, C. Okay, so you have your A, you have your B. Let's say this one is what? Is D. Where you have, let's say it's D. Okay, so it's as simple as that. And from here, you can see that this is already looking like our normal right angle triangle that we've been working on all this while. Our SOHCAHTOA, our Pythagoras theorem. So don't let us forget the sides. Okay, so this side is what? Is 2. Either this side or this side. You are picking anyone. It can be anyone. And don't forget, this one is this line divides the horizontal line into 2. This vertical. So it means this place will be the BD will be 1. This one, the D and C will be what? 1. So don't forget this line divide divide this horizontal line into 2. So it means BD will be 1, DC will be what? 1. Since BC is equal to 2 and is divided into 2 equal halves, BD 1, DC 1. Okay, so I can come here, my BD is what? Is 1. So this is very simple now. So the question I need to ask myself is for me to now get my what? Get my what? AD from Pythagoras theorem. Okay, I can get my AD from Pythagoras theorem. Very simple. I can get my AD from Pythagoras theorem. So all I just need to do, I'll just say, okay, um, from Pythagoras, from Pythagoras theorem, from Pythagoras theorem, okay. So BA square equals BD square plus AD square. Okay, don't forget. So it means, what am I trying to do? From Pythagoras theorem, BA square hypotenuse, okay, equals adjacent BD and what? Opposite. Anyone can be opposite or adjacent. It depends on the angle we are looking at. Are we looking at angle 30 first, or are we looking at angle 60 first? But in this case, we want to get our AD square. So we are using our Pythagoras theorem. We already know our hypotenuse. So what's our BA? Our BA is what? 2 square equals, okay. So you already know our what? Our BA. Our BA is what? 2 square. Then our BD is what? 1 square plus what? AD what? Square. So now from here, we can go ahead and get our what? Our AD square. We can get our AD from, so we can get our AD from here. So what do we need to do here? So it means that this one, 2 times 2 will give us what? 4. 1 plus what? AD square. So therefore, what do we need? Therefore, we now say AD square. This will be AD square equals what? 4 minus 1. What am I trying to do here? I'm making AD square to stand alone. I've told you from my initial presentation, first presentation, you are moving your 1 to the left hand side. It's crossing equal sign. It's changed to what? Negative. 4. 1 is crossing equal sign. It's changed to negative because 1 here is positive. It's positive here, but we don't usually write it. Okay? So when positive is crossing equal sign, it's changed to what? Negative. 4 minus 1 is what? Is 3. So it means that implies, okay, uh, so we can now say that implies that AD square equals what? 3. You find the square root of both sides to remove these two. Okay, so it means AD equals what? Square root of what? Square root of 3. So from here, it shows that my AD here, so my AD is what? Root what? 3. Okay, so that is what? Root 3. AD equals what? Root 3. So from here, I can now say that how can I get my sine theta, cos theta, and what? Tan theta. Okay, so let's pick 60-degree first. We are picking angle 13 first. So since we are picking angle 13, Now look at it very well. Where is angle 30 facing? That's the question. You know, I've mentioned it when we started. Look at where the angle 30 is facing. Angle 30 is facing this side. So it means this side is automatically opposite for angle, no, not angle 30 now, angle 60. Sorry. So angle 60 is facing the side. So it means automatically that side becomes what? Opposite. We already know our hypotenuse. I've said it over and over in part 1 to part 6 that where the right angle is facing is already hypotenuse. So it means this place is what? Hypotenuse. Okay? It means that place is what? Hypotenuse, because our right angle triangle is facing that side. Okay? So because we are considering angle 60, which is what? Angle B, ABD, angle ABD. So which is angle 60. Okay? So instead of me saying angle 60, I can say angle B because this is where B is. So because this one is facing the side, it's already what? Opposite. So it means the other one will be what? Adjacent. So don't forget, we are looking at angle 60 first. Okay? So you now say that implies for angle angle 60 degree. Okay? So we're looking for we're treating angle 60 degree first. So for angle 60, it means that we can use our what? Our SOHCAHTOA. Okay. So this means that implies SOHCAHTOA. Okay. So for SOHCAHTOA, then it means that in part 7, in part 8, we'll continue from here to show our sine 60, cos 60, and what? Tan 60. So we don't want to rush it. We want to ensure that it's as short as possible so that we won't get bored. Okay, so continue. You're watching it. I could see a lot of views. So, but you're watching it, please like, comment, and share so that we can reach a lot of young minds for them to see that these things are what? Are simple, are just like chin chin and pure water. Cheers.